Right, hi guys. Sorry, I don't know if you saw that, heard that. I don't know beforehand. I was having a few problems, technical issues, just getting online here. Anyway, hopefully you can all hear me out there. And is Michael out there? Just give me a thumbs up, Michael. Michael from Air Maths Tuition is giving me a hand as usual again this morning. He'll be answering all your questions, so thank you very much, Michael. Thanks, yep, got a thumbs up there. Okay, so what are we going to be doing today? We're going to be doing 5 quick questions in pure maths. I've had some replies back from many of you that you'd like to see some not pure maths, sorry, some statistics and mechanics coming up. I'm going to be doing that next week, okay, regular time slot, 10 o'clock. I'll put some questions in there. I'm trying to vary the standards. Some of you guys have been saying, can you make the questions harder? That's a little bit difficult at this moment in time. I just want to gauge the feeling. So we'll just see what we get back. Okay, so let's get started for today, and hopefully you all got pen, paper ready. And we'll be doing some questions, by the way, on some partial fractions, find the equation of a tangent to a curve, also looking at discriminants of equations, geometric progression, and a little bit of trigonometry where we look at small angle approximations. So if you're stuck on any of these, you can always go back and look on my website for some video tutorials under these various names. What else can I say? Oh yeah, don't forget, in the description you'll see that I've added links to various things. Certainly I've created a playlist for all these short workouts so you can check out earlier ones. Okay, so let us get started then. Okay, good luck, and we'll go from there. Okay, so let's just remove that screen and we'll get on then with the first question. So we've got these partial fractions here, okay? 2x minus 1 all over x minus 1, x minus 2. Written in this form, you've got to find the values of a and b. So if you can just check out what those are, let us know what your answers are as usual. Okay, we'll see how you go. So as I say, if you are stuck at any time, you can always check out my video tutorials on the website, and we're going to move through these quite quickly, so you might want to come back later on and replay the video and pause it in various sessions, okay? Right. Egbert seems to think he has an answer. Need to know what those answers are though, Egbert, if you can enter them in. Okay, and we'll just see. There's several ways that you can do this. One's going to be a quick way, the other way I'm not that, I don't generally like that other way. Egbert, you've got an answer. Does anybody else agree with Egbert? Let's see what other answers we get coming in. We got Claire coming in with a equals 1, b equals 3. Can't be sure that that's right yet. So any other answers? Okay. Someone's saying use the cover up rule. Good rule. Okay. Egbert's now coming in with, I believe, a is -1, b is 3. Got some more answers coming in. Interesting answers. Okay, just run it through for a few more seconds. Anybody else? Okay. Seem to have a lot on b equals 3. And we've got some answers on a. Okay, well, unless I've made a mistake, I hope not. This is going to be really embarrassing. And I've just seen that I have made I've made a mistake on my earlier solution. Okay, anyway, no problem. Okay, here we go. Okay, my mistake is here. A is -1, and yet I wrote it over here. Okay, so let's just change that. All right, so this one here should be A is -1. Sorry about that, guys. Anyway, A is -1, B is 3. Well done to all of you who got that. So what I did here, this is the way I prefer basically, is that I've put it all over a common denominator here, lowest common multiple of x minus 1, x minus 2, and it's just there. And yeah, so simplify your fractions on the top in the numerator here. Compare the numerators, and you can see that when x is 1, that takes out this term here, and you're going to get 2 minus 1, which is 1, equals negative a. And that would leave a to be -1, not as I put a as being 1. Let x equal 2, put it in here. You're going to get 0 on this term. This term's going to be just b, so you're ending up with 3 there. 3 equals b, b equals 3, okay? The other way you can do it is just to compare coefficients of x. If you do that, you've got a 2 here, and if you expand this bracket here, you're going to get a there for ax and a b for bx there. So you've got a plus b equals 2. Compare the constants, you've got -1 there, minus 2a, minus b there, and you've got another equation. Simultaneous equations there, and you can see that you'll end up with a is -1 and b is 3. Okay, so a bit of a blunder on my part when I wrote a equals 1 there. Right, okay. So well done to you guys who got that one. Right, we're going to move on now to the second question, and this is on tangents to curves. Okay, I've got you're going to get you to find the equation of the tangent to the curve y equals x cubed at the point A where x equals -2. So have a go at that one. Let's see what you get back on that. Right, how are we doing? I must admit, whenever I do a coordinate kind of geometry question, I tend to go for sketches. I know you might be up against the time here, so you might not draw a sketch, but when we come back to the work solution in a few moments, you'll see a sketch in front of you. Hopefully help you through. So how's it going out there? Okay, we have an answer. That's quick. Y equals 12x plus 16. You're all coming in. Well, I've got some answers with 12x plus 16. Some of you guys might have alternative forms. I'm not saying y equals 12x plus 16 is correct yet, although there does seem to be a few people coming in with that. Okay, so good to see some quick responses here. As usual, it does give you a chance to work under pressure. Okay, we've got some variations of y equals 12x, y minus 12x plus 6 equals 0. There's another variation. Okay, so I think it's about time we just give you the answer, okay? Right, let's just go through this one. So here's the answer. It did say, and you wanted to look out for this, by the way, in exam questions, find an equation of the tangent. I'm not asking you to put it in any particular form. And you notice that my final answer really was this one here, y plus 8 equals 12x plus 24. It is an equation for the tangent. Mind you, you could simplify it, as many of you I can see have done. It comes out as y equals 12x plus 16, or you might want to rearrange it into the form ax plus by plus c equals 0, which is quite often asked. Okay, so just quickly run through this in case you did want to know how to do it. It's a bog standard type of question. You've got a curve and you've got to find a tangent to it at a given point. In this case, x equals minus 2. I'm using this form. I think it's very quick for the equation of a straight line. You only need to work out the gradient and know a point x1, y1 on the line. So we start off substituting x equals minus 2 into our equation of our curve. We end up with minus 8. So we know the point A is minus 2 minus 8. We differentiate to get the gradient of the curve at any point. Substitute x equals minus 2 into dy dx to get the gradient at the point A. That'll be the gradient of the tangent. Turns out to be 12. And then I can just substitute my coordinates, minus 2, minus 8 for x1, y1 respectively, into this equation form here. And along with m being 12, substitute that in and I get that as an equation of the tangent. And it's up to you whether you want to simplify it further in the form y equals mx plus c, or as I said earlier, ax plus by plus c equals 0. Okay, so okay, we're coming on to the next one. Now with the next one, okay, we have got this one. It's on, well, I'm not going to say, okay? I like to think that you might know at this stage. But we've got this equation, x squared plus 3qx plus q equals 0, where q doesn't equal noughts. It has equal roots. That's equal solutions, okay? Find the value of q. So, let's see how you get on with this one. This one should be fairly quick for you guys. Okay, quite a common one on exam papers, so hopefully you'll get some practicing on this. Yes, ragazzi, it's called the discriminant. That's what you're going to need to use. Well done. Got to know about the discriminant. We've got an answer already. Q is 4/9, but is it the right answer? Let's see if any of you other guys come in with 4/9. Jasmine's got 4/9. Anybody else? Again, not saying it is the correct answer. Harry's saying yes, it is. Let's see if we've got any other answers. Okay, well, we're going to move on. Yeah, rainbow's coming in. A lot of you coming in now with 4/9, and well done, it is 4/9. So let's just show you guys out there, if you've got any problems, look up the discriminant of a quadratic equation on my website for tutorials on this. But I'll just take you through very briefly. If you've got a quadratic equation, you should know the formula here. This part underneath the square root sign is called the discriminant, b squared minus 4ac, and by checking out the value of b squared minus 4ac, if it equals 0, you get equal roots. If it's greater than 0, you get real and different roots, and if it's negative, less than 0, you get no real roots, okay? So I've looked at our equation here. We've got a is 1, b is 3q, c is q, and for equal roots, we've got b squared minus 4ac should equal 0. So I've just substituted those values in, got a quadratic equation in q, which I factorized. Q would be equal to 0 if that factor, well, that is a factor, so q could equal 0, but we're told that q doesn't equal 0, so we've got to ignore that. That means this other factor, 9q minus 4, has got to equal 0, leading to q being 4/9. Okay, So I know I've gone through that very quickly, but the video tutorials I've got out there on my website do go into more detail. Okay, so well done guys for getting the 4/9. Right, we're moving on now. Okay, 2 more to go. Question 4 now coming up on geometric progressions. The third term of a geometric progression, GP for short, is 200 and the sixth term is -25. Find the common ratio. Okay? Nice one on geometric progressions. We had one on arithmetic progressions just, I think it was in the first maths 5-day workout. So good to brush up on these things. Okay, we have an answer coming in at -75. So does anybody else agree that that common ratio is -75? We've got Jasmine with common ratio r equaling 2. So we are having differing answers here. Anybody else want to volunteer an answer? Okay, another r equals 2, -75. Interesting. What do I mean by the common ratio? Well, the common ratio is where you keep multiplying each term by a constant value throughout the sequence and it gives you the next term. Okay, we still have some other answers coming in. We've got r is -0.5, the equivalent to r equals -1/2. We also have a -2 answer there. Okay, right, well, I think for some of you guys, if you haven't covered, as I say, geometric progressions, again, do check out the tutorials on that. I most probably ought to start putting some links in the description to where you can find some of these tutorials. I'll start to do that most probably in the upcoming ones. Okay, so let's go and check out the answer. For you guys, I can see that some of you have got -1/2 or -0.5, you'll find that you are correct. Okay, well done. And just briefly, if you're looking at geometric progressions, we've got a sequence of terms here. A is the first term. You multiply each term by a common ratio called r here, and that will give you ar squared, ar cubed, and so on. And the nth term is always given by ar to the power n -1. You won't need these facts for this question, but they're just the sum of the first n terms of a geometric progression given by this formula, and the sum to infinity is given by this formula, providing that the common ratio is between -1 and 1. And we'll be testing that in later 5-a-day tutorials. Okay, so, right, just quickly then, I used this idea here about the nth term. When I saw that the sixth term was 200, okay, no, it wasn't, sorry, sixth term was -25, I have ar to the power 5, remember you subtract 1 from the nth term there, ar to the 5 equals -25, and then the third term was 200, so ar squared equals 200, and then I divided my equations, all right? That meant that the a's cancelled, leaving me with r cubed equals -25 over 200, which gave me r cubed is -1/8, and I could take the cube root to get r. And if you take the cube root of -1/8, you get r equals -1/2. Okay? So there you go, r equals -1/2. I'm trying to also, by the way, put up a lot of questions that don't necessarily mean that you can use the calculator, because I know a lot of you guys out there could use the calculator, and I would prefer in many ways if you could work with pen and paper. But anyway, there we go. Right. Question 6, here we go, last one. No, sorry, question 6, sorry, question 5, the last one. Okay, so small angle approximations. If theta is small and measured in radians, use the small angle approximations to find an approximate value of 1 minus cos 3 theta all over 3 theta sine 2 theta. So you've got to know a little bit about your small angle approximations. So, okay, see how you get on with this one, and we'll wait for some answers to come in. You should be able to do this one fairly quickly without the use of a calculator. I'll give you some notes, quick notes very shortly when we display the answer if you're unsure of this. We've got an answer coming in, 3/4 from Ben. Anybody else going to give us an answer? Again, if you go on my website, you'll find under small angle approximations a question very similar to this one. Okay, I just adapted the one that's on my website on the exam questions under small angle approximations. Okay, we have 0.75, the equivalent, yeah, to 3/4, another 0.75 coming in. Okay, so yes, well done guys, you've got it, 0.75 or 3/4. Let's show you how it works. When you're dealing with small angles, that angle has to be in radians. So if theta is small and measured in radians, it turns out that sine theta is approximately the same as the angle theta. Cosine theta is approximately 1 minus theta squared over 2. If you have got a calculator, just type in radians mode, for instance, a very small angle like 0.01, for instance. That will have to be in radians, and you should find the sine of 0.01 is approximately coming out as 0.01, and you can try it out with cosine theta. Okay, I'll leave it up to you anyway just to do that. But taking this question then, using these ideas over here, you can see that all I've done is replaced cosine 3 theta, the 3 theta here, I've written it in place of the theta. So we've got 1 minus 3 theta all squared over 2, which I've written here. 3 theta here stays exactly the same. The sine of 2 theta, replacing the theta here with 2 theta, becomes that it's approximately the same as 2 theta, which is what I've written there. So you just expand the brackets and you'll find the theta squareds cancel out. You end up with 9 over 12, the 6 with the 2. 9 over 12, reduce it down, and you get 3/4 or 0.75. So, well done if you got that. Okay, so that brings us now to the end of this. Okay, I'll just bring myself back on. Yeah, guys, so well done for taking part in that. I hope you found it useful and that you'll continue to come back. I haven't had a chance really to read your comments that are coming through, but I will do in time. Do have a look at the description below, and as I say, you'll find more links there, also to the up and coming videos, the workouts I should say next week. Okay, just remains for me to say have a good weekend. And thanks for watching, and hopefully see you again on Monday. Okay, bye for now.